So now we're going to talk about, well, what happens if we need to eliminate something? Like we got lucky on the last example when we added them together, the x terms just dropped out. That doesn't always happen. Okay, so here are the steps. First, you got to get each equation in the right form. Okay, we talked about that. Ax plus by equals c. Okay, you multiply either one equation or you might have to multiply both so that one variable will eliminate. Now we know if we have an equation, a equals b, that you're allowed to multiply by, you know, the same thing, a number on both sides, right? That's allowed. So as long as c doesn't equal 0, you're allowed to do that, okay? So you can multiply by whatever you want, positive number or negative number, as long as you multiply to both sides, okay? Well, you're going to create that situation so that something will eliminate. And then when you add them together, so you kind of have to look ahead. Okay, once you get that done though, you're going to add the equations. You'll solve your equation and back substitute and check. Those steps are the same. Okay. So here we have our example solved by addition method. Now, don't write this down, but you might be saying, okay, I'll just add them together. 12x minus 6y equals 24. Well, it's not that that's wrong. It just doesn't get us anywhere. So don't do that. And the reason it doesn't get us anywhere is because nothing eliminated. I still have two variables, so how am I going to solve that? It's not helpful. Okay, so it's not that it's wrong. We can add them, but we're not getting any place. And we're trying to solve this system of equations. So I look at the x terms. Gosh, if they were both like 9x and negative 9x, that would work. And I look at the y terms and I say, oh man, if it was an 8, I got negative 8y right here. If this were just an 8y, then my world would be a better world. Okay, so in fact, that's what I'm going to do. I'm going to multiply the top equation. Remember, I get to multiply by whatever I want. I'm going to multiply it by 4. Okay, now when you do that, I usually write it this way. Sometimes I put the 4 on the left, but you're got to distribute that to each term. Sometimes people forget that. So my new equation becomes, let me rewrite this for you so I can make it a little bit, I kind of ran out of room over to the right there. I'm going to multiply that by 4. The bottom equation, I'm not going to do anything with it. I'm just going to let it ride. Okay, so my new equation up here, I'm going to have 12x. I'm going to have 8y plus 8y. And I'm going to have, oh, what's 4 times 48? 192. I might have to go get my calculator. Okay, I think it's 192. All right. The bottom equation, I don't need to change anything because I've already got the negative 8x. So I'm just going to copy it down. Okay, hopefully you can see that the 8y and the negative 8y are going to drop out. Okay, when we're eliminating, you have to have one positive and one negative so they add up to 0. So the coefficients have to be opposites of each other. Okay, now my x's aren't going to eliminate. I only need one variable to eliminate. In fact, I don't really want both of them to eliminate. Sometimes that happens, but not here. Okay. So I'm going to add the equations. What's 12x and 9x? 21x. And then the 8y and the negative 8y, those eliminate. That's what's supposed to happen. We're all excited. And then what does it equal? Well, I have to figure this out. So borrow 168, it looks like. Okay. Now, sometimes these numbers get a little big because we're multiplying by bigger numbers. This is to avoid fractions. It doesn't mean our answer is not going to be a fraction. It could be, but we wait till the end, okay? And so it kind of puts it off. All right, so I'm going to divide by 21 because I just have 21x equals 168, so I'm trying to solve for x now. The y is eliminated. And how many times does 21 go in? Times, right? Okay, so x equals 8. Now, that's great. I still have to find y. There's two ways you could do it. Either you could go back to the original system up here, and you can eliminate the x's, and then you could solve for y that way. Or you could just back substitute. Okay. Usually we back substitute unless there's like some crazy fractions or something. So if I were going to back substitute, I'd probably take the top equation, the 3x plus 2y equals 48. Now, what I'm looking for usually when I'm trying to decide what equation to use, I look for smaller numbers and I look for positive numbers instead of negative numbers. I just figure I'll make fewer mistakes. Okay, so I know what x is. X is 8, so I'm going to plug that in right there. 3 times 8 plus 2 times y equals 48. So I get 24 plus 2y equals 48. So subtract the 24 from both sides, and I get 2y equals 24. I'm going to divide both sides by 2, and I get y equals 12. Now, I think I know the answer. I'm pretty sure the answer is going to be 8, comma 12. So remember, you're writing an ordered pair, x, comma, y. X, comma, y. Okay, so that's how we're writing our answer. But let me just double check. Maybe I'm wrong. Maybe I made a mistake. So if I want to check, I'm going to take that bottom equation right here, because I already did the top equation. I'm going to plug in my 8 for x and my 12 for y and see if I get negative 24. And if I do, I'll just feel a little better about the situation. 9 times 8 is 72. And then what's 8 times 12? 76. No, not 76. 96, right? Okay, is 72 minus 96, is that negative 24? Yeah, I think so. All right, so it's all checking out. I was just double checking. 8 and 12 is kind of big numbers. Okay, it all worked out. Now, these problems do take some writing. They take about half a page to do. That's just the nature of the problem.